Oh, yeah.
Well, surprise, surprise, here we are again. Welcome aboard, everybody. The 264th episode of our SBAU Astro Hour for the week of March 16th through the 22nd, 2026, comes to you from our lovely telescope club, the Santa Barbara Astronomical Unit, which is based up in Mission Canyon at the Santa Barbara Museum of Natural History. I'm your humble MC for the Astro Hour, part and parsec of our weekly attempts at
First.
helping to educate the public, as well as our members who are part of the public of SBAU on the rapidly expanding discoveries and theories, accomplishments of scientists everywhere involved in our favorite branch, cosmology. Find us online at sbau.org, everybody, and come join us for a lot of fun of astrophysics, mostly at night, but we do things during the daytime too. Here are this week's topics. It's a great galaxy season, everybody, especially if you got a backyard scope. I hate to sound kind of personal here, but Uranus, which we know as Doug, is in Taurus right now, not far from M45, which is known as the Pleiades. Got a crescent moon, going to pass 5 degrees north of Venus this Friday morning about dawn. And we're going to focus on two major things. Get this, talk about running different ends of the spectrum. Small red dwarf star in Ophiuchus, which is the fourth nearest nearby individual star to our sun, about 6 light years away. Barnard's is just a little bigger than Jupiter. And we're also going to take on the very largest stars. Boy, this fascinates the heck out of me. Imagine that much active matter occupying that much space. Our whole inner solar system could orbit inside. Those are the topics. Oh, incidentally, real quickly, a couple of Sundays ago, they had a light show over Europe at night, and I guess a meteorite went through a house, a roof in Germany in some town. And some guy, some entity here in California wants to put mirrors in space. That'll be something we'll be talking about. I doubt we're going to be behind that. Let's meet the gang in charge. Our beloved president becomes our incredible professor on Mondays of astrophysics, Jerry Wilson. Married to,
Good morning, everybody, and good morning to my sister Joyce and my grandkids, Calvin and Riley.
well, people that you're going to go see in Eugene, Oregon are included in that, or do they know we're
Oh,
down?
that's my grandson Riley.
Oh, that's the one. Is that the one that we met Saturday night at
Oh, you
Starbucks?
met Calvin.
Oh, okay. Good kids. Of course, your duty is to spoil those kids rotten, Grandpa. You know that. Here's our incredible outreach guy who spends a lot of time outside, mostly at night, Chuck McPartland, who's also married to a Pat.
Feed those mosquitoes.
Do you still go out? Yeah, 200 times a year is more than half the year. You know that. More than
Yeah.
half the nights of the week you're out doing something, you're teaching at
Well,
school.
it's not always at night, and sometimes it's multiple events a day, so I cheat a little.
Well, I hope you check into a spa once a year for a week or so. Here is our incredible man who's got astronomy in his blood, Tim Crawford,
Hello. Hello,
married to
hello.
Karen and does it all and loves it all. Joining us on screen, the man we got from Westmont, from his own lab when he retired years ago. And even before that, I guess he was editing our newsletter. Tom Whittemore
Hi.
is on
Morning.
board. Welcome back, Tom.
Oh, there's a cat.
For a
How's
moment,
Maureen?
it looked like a crow.
Yeah,
Astro cat.
yeah, okay. Well, gentlemen, we got silly stuff to get through. That'll put us all in a good mood. The president sent us, I believe, 7 mostly science-based cartoons, and you're not going to believe some of these, including those puns at the end. I'm thinking of letting each one of you read one.
Yeah.
In the meantime, here we go. Let's start the hour with the president's forwarded tunes. Okay, this is Walking with the Guru at Night. You might have to enlarge. Well, it's going to go off the screen. If what's happening there, Jerry?
It says he's walking along with this person. I don't know what it is, but these are Japanese characters.
Oh, is it okay?
Anime. Oracle, are we done? Are we alone in the universe? Yes. So there's no other life out there. There is. They're alone too.
There. He's very right, isn't he? We're never going to get together with anybody. There's no extraterrestrials that can make it here.
Uh-huh.
That's great stuff. Okay, this is an attempted murder, which is what, a crowd of crows needed?
Yeah, a group of crows is a murder of crows.
So you need
They
more
can
than
only
two.
get two together.
You suppose they got that name because people want to murder them outside their houses in the street?
No, I
and
don't think so. The way I heard it, it was a bunch of English language scholars and wealthy gentlemen that were sitting around one night sipping port wine or something and just making up names for large groups of animals.
And so Oxford
Okay,
has to pump
this is Calvin and Hobbes cartoon.
without
Dad, why
harm.
does the sun set? It's because hot air rises. The sun's hot in the middle of the day, so it rises high in the sky.
Right?
In the evening, then it cools down and sets. Why does it go from east to west? Solar wind. Dear,
Sounds like AI to me.
this is an example of what in psychology is called crazy making. The kid can't get can't get the innuendos here, and they remember it as gospel.
Yeah, well, there's a lot of that going on. This I got the gist of. You, Chuck, you want to explain this to us? What are we looking at here?
Okay, this is an XKCD, it looks like, and it's a chart of how to recognize planets and bright stars, and they basically all just look like bright little dots. Although that's not true. Betelgeuse should look a little orangey, and
Saturn's not on there, is it? Oh,
yeah,
yeah,
Saturn's there. It should look a little yellowish.
On my screen, Betelgeuse is a little yellowish.
Oh,
And so
okay.
is Antares
Okay.
and
Huh.
Mars, but it's very subtle.
So this is all naked eye views, right?
Yeah.
Got it. Okay. Ah, the different copy sizes. What do you get from this, Mr. Mr. Tim Crawford?
Yeah, this is something that they have in the coffee sizes. You go to Starbucks or wherever they have the size tall, which a lot of people won't get. The grande, okay, people will get that, but the day after daylight savings time, they get the bucket.
Take it by the bucket.
And that's not enough.
Yeah.
I'm still not switched over to daylight savings time.
I heard that the national average is 3 cups for everybody, right?
The what?
3 cups of coffee a day, and I do 2, and my doctor says don't do any anymore.
Oh,
I do
I'm gonna
5.
I'm gonna let Whittemore interpret this for us.
The only thing a flat earther has to fear is a sphere itself.
I like that one. I like that one.
FDR would be proud. All right, why don't we just do a round robin and take these one at a time? Jerry, you want to start and do the first one, and then Chuck, and then
Okay.
Tim, and then Tom?
so
Okay.
what if I don't know what apocalypse means? It's not the end of the world.
Okay, Chuck.
I wasn't originally going to get a brain transplant, but then I changed my mind.
Tim?
How did I escape Iraq? I ran.
Whittemore?
My first job was working in an orange juice factory, but I got canned. Couldn't concentrate.
I'm going to do the next one. You're living, you occupy space, and you've got mass. You matter. Dark matter in my case.
Yeah.
Harry?
What do you call a snobbish criminal going down the stairs? A condescending condescending.
Okay, Chuck.
Oh, I got the worst one.
Oh dear.
A man walks into a zoo where the only animal was a dog. It was a Shih Tzu.
Okay. Next is Tim.
My math teacher called me average. How mean.
Tom Whittemore.
Why do they call it a Czech? Why not Yugoslavian?
I love these. They're not all exactly puns either. Puns are plays on word, aren't they?
Yeah.
People who say they suffer from constipation.
They're full of shit.
Enough said.
Okay. I couldn't bring myself, even though I've been known to slip it into the introductions.
So, Ron, did you ever hear about the constipated mathematician?
No, what happened to him?
He worked it out with a pencil.
Oh, God.
Oh, good. I've heard that one before.
Tell that on Sunday afternoon at Bruce's testimonial? I don't think so. Okay, let's get into the heavy night sky, gentlemen. I'm looking forward to this. Always do.
Okay, as I pointed out in the talking points. This season is my favorite celestial show. And it usually, I've noticed probably just coincidentally, that it's usually a heavy marine layer this time of year. So we very seldom from my backyard get to see these things. But the galaxies, we're looking out of the North Pole of our Milky Way. And what we're looking at is intergalactic space. The Milky Way is not in the way.
Mhm.
And so we're seeing a number of galactic clusters, the Virgo cluster, the Coma cluster, and several other ones too. What they do is what I'm going to show here is the best of the best. These are the most photogenic and the largest of these distant spiral galaxies. This is what's called the Leo triplet. It's right located here in the constellation of Leo. I like what this guy did for the finder charts. Regulus, Chertan, and right down here below Leo is, and this is Iota Leonis, is the triplet of things. It's M65, M66, and NGC 3628, which we refer to as,
The hamburger.
right,
A hot dog.
okay. So this is the hamburger over here. And these things are easy pictures to take. These are fairly bright galaxies. They're about 8th or 9th magnitude overall, maybe even brighter than that. They make very good objects to photograph.
And you showed it. Finding those is just, just the hindquarters between those two stars,
Mhm.
and easy to locate. And there's another triplet as well, but that's another.
There's several that decrease in size and brightness.
Mhm.
This
just a 2 seconds, 2 cents worth. If you've heard that March comes in like a lion and goes out like a lamb, that's because Leo is rising and Aries is setting.
Yeah.
Oh,
okay.
I didn't know that.
Mhm.
You guys can get in your telescopes what we're seeing. It'll look just
Yeah.
like this.
Oh yeah.
Oh.
It's those are
Okay.
bright.
Can't get all three of them in
Oh.
most amateur scopes.
I can get them, but it's,
I can get them in my F3.3.
yeah.
And I
Sea
can
stars.
photograph.
Sea stars will get them.
Yeah.
Obviously,
Oh, yeah.
okay.
Now the next grouping is the two galaxies in Ursa Major. You take the bottom star of the bowl and the top corner star of the bowl, and you make kind of a curved arc out here about that same distance, and you will see M81 and M82, Bode's Galaxy, and the Cigar.
And on this one, Jerry, Joe Doyle told me that a little trick, and you have to be in a darker sky. There's a little circlet of stars that kind of a hook. They kind of hook over, and at the end of the hook is 81, 82. So I think that just to the left of 82 there, you can see the little group of stars, and I think that's the hook he's talking about.
This group here?
No, over just right there. And it
Okay.
kind of hooks over to 82. And in a pretty dark sky, you can just make those out naked
Yeah.
eye.
Mhm.
Oops.
These
Because
are pretty
otherwise,
faint.
it's
Go ahead.
I can spend 20 minutes trying to find that without coordinates.
Yeah. And it's also, Ron, the time of the year that when the sun goes down, the dipper is up and down.
I
It's really
noticed that
pretty. Yeah.
Saturday night. Those four stars aren't stars, they're galaxies, right? That's
These
what-
two things are galaxies.
Right.
All
Oh.
these are stars.
Oh, the rest are stars. I'm sorry.
Right. And last week, I wasn't here because we were in the Pinnacles, and the skies there are just really, really dark,
bet.
really beautiful. And you could see the three leaps of the gazelle and all kinds of details you can't see here in the night sky.
Wow.
Naked eye, M41, M44, M35, naked eye. Naked eye.
35?
35 was naked eye, Tim.
Whew.
Yeah.
Those are not galaxies, though.
No, they're
They're
open
clusters.
clusters. Absolutely beautiful open clusters.
Yeah.
So
You
you're
could also see the open clusters going right through Auriga. Naked
Yeah.
eye.
Oh, yeah. I know where those
Oh,
are.
is 41 the Pleiades?
Yes.
The
Okay.
Pleiades.
Yeah. Now, this is Bode's Galaxy. It's very dramatic, excellent spiral almost face on, halfway face on. You can get this kind of picture from our amateur telescopes.
The sea stars really go after this.
What's that? Oh, yeah. Yeah,
The
this
sea
is an
star
excellent-
guys really go after this one.
Yeah,
Yeah.
you get the two of them together in that scope.
Two
And
arms.
this is the cigar.
Mhm.
It shows the explosion or the fast streaming of gas from the center of the galaxy. It looks like it's trying to be a spiral, but it's tipped so far on us, you can't really see any definitive. You can see veins through it, but I don't see any arms, a lot of
Right.
gas veins.
And you
It's
can
it's
see a
getting
lot of
tidally,
background. You can see a lot of background galaxies here, at least 10 of them.
Yes.
What
it's
did you
getting
say,
tidal.
Chip?
I'm sorry. Go ahead, Ronnie.
No, I was asking you to tell us what you were saying.
It's getting tidally disrupted by M82 or M81.
Yeah.
And so it's a starburst galaxy, it's called, and there's lots of supernovas going off. So that's what's driving a lot of this hydrogen that's
Yeah.
spilling out of it here that looks red.
And you can see the shape of it. It bends over this way. And these faint white lights, those are star clouds, just massives of unresolved stars. And down here, it bends up. That's tidal distortion from being too close to M82.
But how often does the galaxy have jets coming out from its center?
Fairly often.
We
Yeah.
do.
Does it come from the supermassive?
I don't know that. We'd have to do a session on that.
A lot of it comes from just supernovas in the crowded section of
Yeah.
the galaxy.
What I've heard is that M82 has for the mass of the galaxy, it has about 5 times the amount of supernovas going off in them, and that would be normal for its mass.
Mhm.
So it's really
Starburst.
yeah, it's really going off in there. It's a pretty wild place.
So all that color is not stars. That's just nebula
So
material,
the
right?
red stuff is gas and dust.
Yeah. You'd think they'd form some stars, wouldn't you?
Once it
Well,
calms down, I'm sure it will.
Yeah, it's hot and it's moving fast. It's not
Yeah.
going to form stars right away.
And the museum had one from it was either NASA that had a big portrait of actually an image, and it was done in visual and infrared and ultraviolet.
Yeah, that's 101, Tim.
Oh, was it?
Yeah. Up in Ursa Major.
Oh, I thought it was 82.
They have
No.
basically this image of M82 in the. They used to have it in the space lab.
Yeah,
Yeah.
yeah.
A wall size version.
Yeah,
Oh, okay,
101's in the Palmer, though. 101, Tim, is on the wall of the Palmer.
Oh, okay.
Huh,
Okay, next
fascinating.
is
104.
the Sombrero Galaxy, M104.
Tricky star hop.
Yeah, so you go down here to Corvus, you find the two top stars, Algorab and Guyana. And you just find there's a faint stream of stars that goes up from Guyana and heads toward M104. It's not that difficult. It's in an open area. It's not that difficult to find. And
There's
it's-
an arrow of stars pointing
Right,
right.
that's the way I learned it.
Yeah.
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 That little blob that's just to the right of it in the blow up. There, I think that's the little arrow that kind of points at it.
Yeah, and
Yeah.
it points right to it.
It's not really
Yeah.
showing
This,
that way
this
here.
makes
but-
a big arrow.
yeah.
Goes back and-
Yeah, yeah.
Yeah. I saw this in a 61-inch above Tucson.
Ooh.
It was amazing.
Well, tell me it was a Mexican astronomer that discovered it.
Yeah.
It's really blown out.
God, look at all those background galaxies.
Sombrero is supposed to look like a sombrero.
Oh, yeah.
To me, that connotes one side as a bulge, the other side wouldn't.
It used to look like a fedora, but it changed.
Let's see that yawn. Got it.
There's a joke in there somewhere.
Yeah.
Oh, that's great.
Look at all those distant galaxies.
What's the dark edge about?
Right, there's one,
Dust lane.
there's one, there's two,
There's a pair, yeah.
and there's one. Yeah, there's all over the place. They
Up-
That's the
upper
brim of the
right.
sombrero.
Upper right
Yeah.
corner, there's a couple of needles.
there. Those are edge on. And this one is almost perfectly edge on. you can see this very dusty ring around the edge of the galaxy.
The brim of the sombrero.
Yeah.
Mhm.
Wow.
And it's got a huge number of globular clusters.
Oh, really?
Yeah, I think we covered that. Early spring looking north after sunset, the Whirlpool Galaxy. This is, again, in Ursa Major. There's the bowl, there's the handle, the last star of the handle. You go a 90 degrees up, not quite this distance, up here from Alkaid, and you get to M51. It's kind of easy to find in our little scopes because it's quite bright. Now, when I say quite bright, they're all faint fuzzies, so don't expect it to glare in your eye.
Eight fuzzies. We see this full on, not edge on, right?
This is a pair of interacting galaxies.
Right. Yes.
Oh, it's a pair.
So this is the Whirlpool M51, and I forget the M number for the NGC number for this.
Yeah, I did too.
We have binary galaxies.
They just came close and they stuck together.
Well, the blob on the right is a galaxy, right?
It was.
Mhm.
Are they merging?
Eventually,
They're swapping a lot of material.
Okay. Interesting.
this is
Okay.
definitely a Hubble picture.
Two main arms again.
I
Yeah,
have
the companion is 5195,
Mhm.
and actually Whirlpool is 5194. So that's a
Okay.
good way.
Yeah, Mike Summerman at Westmont took an amazing image of this.
Wow. Okay.
Next is a string of galaxies.
Yeah.
It's also near the rear end of Leo, Nicoma Berenices, and above Virgo. These are big clusters of galaxies themselves. We're sort of part of the extended Virgo cluster, I believe.
Wow, they spelled Coma Berenices wrong. Oh well.
Yeah.
Yeah.
Forgot a letter.
Some of these are in foreign languages. One time I had several charts to show that were in Spanish. Interesting. So anyway, it's a string of galaxies. And right here, it's called the eyes.
Mhm.
And it's, like I say, behind Leo.
The bit on the right looks like a little face, like a
Right, the
questioning
happy face, Chuck. It's the
Yeah.
happy face.
I don't think I've ever seen this.
Oh, well, you need a wide view, Tim. There you go. There's the smiley. See?
Yeah.
Oh,
see, two
okay,
eyes
yeah.
and a faint smile.
Mhm.
So
an
this is a
eyebrow.
chain of distant galaxies. This is a galaxy too.
Mhm. And there's the chain, Arcturus chain coming down.
The second from the right has something above it. Is that a galaxy?
Yes.
Oh, yeah.
Yeah, these are edge-on galaxies.
Right. It's a
Wow.
very rich region.
That's
Virgo-
kind of the heart of
Virgo.
the Virgo cluster,
That's right.
or Coma. I don't know which they class it in. I think Virgo.
This in a 101, this would be pretty visible.
Oh,
Yes.
yeah.
Yes.
In your 8-inch, Tim, it'll stand out, especially the smiley face.
Yeah,
Okay.
the Dark Knight.
And I think that's 87 down lower left.
Mm-hmm. The 500-pound gorilla in the Virgo cluster.
Okay. Now we're going to switch to inside our solar system very briefly. This is where Doug is right now. It's
Doug.
just below the Pleiades, which we got a good look at on Saturday night, naked eye. I mentioned how to use averted vision to some people, and several other people said, "Oh yeah." So I guess it wasn't generally understood, but it gives a good view of Pleiades. It's up the Taurus with Aldebaran is up here, and Uranus, Doug, is down there. Now the reason I put it in is because the Hubble has taken a very good picture of Uranus, showing its rings. They're not as dramatic or as extensive as Saturn's rings, but all the big planets, Jupiter, Saturn, Uranus, and Neptune, all have a ring system. It's very difficult to catch these in an amateur scope. You
I
have
thought
to,
it took flybys of NASA craft to see them. I didn't know you could see them from this distance with any kind of a,
They got the first hint of them with occultations, Ronnie.
Yeah,
is that right?
The Voyagers.
This is the one, this is the gas planet that's tipped on its side, or is that Neptune?
Yes.
yeah,
Mhm.
this is the one on the side. You can see a storm down here. You can see atmospheric bands and things rotate, stretched out by rotation. So the poles are here. And you can't see this in your amateur telescope. What it looks like, because it's about on the order of 2 to 4 arc seconds apart. And in a small scope, on a good night, these stars are 1 to 2 seconds apart because of the point spread function in your scope. So it's very hard to pick out the planet when it's about the same size. But if you look at things and study it and go to higher magnification, you'll see that this is actually a disk and not a point.
Did I hear once that the rings around Saturn are eventually going to disappear, go away, whatever gets absorbed by the planet?
Yeah,
that
don't
mean-
hold your breath, but yeah.
So that probably is going to happen to all these little minor rings around the other gases, right?
Yeah.
Makes you wonder, why are they there in the first
And
place?
new ones will form.
They
Yes.
form from collisions of things that are orbiting,
Really?
some of them retrograde.
That don't coagulate back into a ball, they just stay as a ring.
Well, yeah, the collision spreads them out and then they gradually fall into the planet.
Just depends how hard they hit each other.
Yeah.
And is the same process in place with the asteroid belt, only a solar scale?
Yeah.
Solar system scale, yeah, sort of.
Huh.
Okay.
All right.
Now on what's the 20th? Is this Thursday or Friday? Friday. The crescent moon, very thin crescent. Right here, you see a lot of earth light, earth shine on the back side of the old moon. It's called the.
It's
Oh.
blown out here, so it looks like a full moon, but yeah.
Yeah, it does too for me. And then Venus is down here. The size of what's drawn here indicates brightness, not actual size. Venus is very commanding of the sky this night. 40 minutes after sunset, looking west.
A Turkish flag sort of view.
Yeah. Yeah, that's right. Okay, there's a very interesting star running around here called Barnard's star. And it is located in Scutum, where I don't see the words. Oh, I guess it's
An
in
Ophiuchus.
This looks like
Ophiuchus.
Ophiuchus.
Yeah, it is. Something
Well,
else we're about to get
Scutum
to.
is your very large star that you're coming to a little later.
Oh, okay. Thanks. So anyway, this is the fastest moving star in the sky. Now this is at 9 o'clock in the evening. This is in a very crowded region with lots of stars. And this is from my planetarium software. And I just cut the wealth of stars out of it with a limiting magnitude, put the cursor where the star is. And this is closer in, and you see this pointed feature right here. Going back, that pointed feature is right there. So we're zooming in quite a ways. What's that?
Yeah, I didn't realize how much you had zoomed it.
Yeah.
What's the pointed feature?
The pointed feature is just a signpost.
Bunch of
asterism.
stars that form a point. Okay.
It's an asterism.
But they're farther away than that. That's one of our close neighbors, isn't it? That Barnard.
Yes, it is. It's about 9 light years away, where Alpha Centauri is about 4.5 light years away. But this is going to come close to us. It's going to become the closest star to us in a few million years.
And it's 6 light years right now.
Okay.
Yeah.
That's what you said in your talking points. Does it have a stellar system of planets?
It does.
Yeah.
It does, huh? Just like Alpha Centauri.
So it's a red dwarf. It's going to last a long time. This is comparison, size comparison to our sun and
And
our planet Jupiter.
wow.
And the planets around Barnard's star are all very much closer than our planets are to our sun.
I thought those would be brown dwarf, starting about brown dwarf size that haven't ignited yet.
Brown dwarf is later. These
Later.
don't ignite, they just cool off.
But Barnard's is a red dwarf. It's a fully functioning, fully
It
fusing.
has fusion going on in it. But it will eventually stop fusing and just start cooling off. And then it'll become the brown dwarf. And then it'll become a dark star, a black star. Not a black hole, but a black star.
And this
Well, I
one
heard
is
the
moving.
red.
Go ahead, Ronnie.
I just heard the red dwarfs live forever.
For a long time.
Seems like it.
Yeah, trillions of years. I took a picture of Barnard's star and compared it to a 1950s picture, and it's moved quite a ways. And it's actually moving so fast that in an amateur scope, you can take a picture of it and then say 2 years later, go and take another picture and see quite a bit of motion.
Well, how
So
close?
if you could live close enough to that star, you'd get a ride to another complete different location, huh? In a matter of time?
That's true of being on any planet around any star.
Yeah.
Oh, okay.
Yeah, we're going around the galaxy.
But it's coming this way, and how soon will it be, and how close will it be?
We're getting to those things. Just a sec. Now, let's see here. Okay.
Guess we know the name of the astronomer who discovered it.
Yeah.
Yeah.
You'd think there'd be all kinds of pictures from Webb of that sucker by now, wouldn't you? How many Proximas does it have, you know?
Oh, wow. Look at that.
There's that triangle, that arrowhead of stars. And right now it's about in this position. So this is 1940 to 2056, the proper motion. That is the motion we see perpendicular to our line of sight.
You know I keep asking this, but this isn't the one they call the flying whatever it is.
No,
No.
that's Piazzi's star. Yeah.
Mhm.
Okay.
That's in Cygnus.
Okay.
It's going up
Well,
in our
That just-
direction,
that's just the orientation of the star map.
Yeah, I could have turned it over
so it's coming toward us.
a little bit, mostly going past us.
Oh, okay.
They took a look at the neighborhood and said, yeah.
But if it's the fourth most distant, there's two others between Proxima and it that are even closer, I guess, than
Well,
it is.
the main stars in Alpha Centauri.
Is that what it is? Whittemore, what do you got to say about all this?
This is very moving topic.
Okay, now here's that. This is upside down. So here's the that asterism that we looked at earlier.
Flip left to right. Yeah.
Yeah.
Tommy. It's a movie.
Yeah, these are actual photographs, not calculated position. So
You
So
can see
you
how
can
the
see it.
seeing was different.
yeah,
So pretty much everything is moving and everything is spinning. There's
Yeah.
very few things that are stationary and still
Relative to what?
relative to I don't know, to whatever they relate it to, you know. It's the background.
oh, that's probably washed out.
Barnard star.
E. Barnard. He was up
Dark
at,
Nebula fame.
yeah, he was up at Lick.
Okay, see this?
Yes.
Okay. This is distance from our sun. The bottom line is zero distance. And this is the outer region of the Oort cloud. Distance here. Distance in light years, so out to 1.5 light years, the Oort cloud. Here's Alpha Centauri, around now.
In 20,000 years, right?
Yeah, yeah.
Oh, that's right, from this point, yeah. So this is now. Yeah. So here's Alpha Centauri. It's coming, I think it's coming in.
So that's Barnard's star. Alpha Centauri is the red
okay,
line
you're
right above the yellow.
Okay. I'm just going to shut up and let you guys take it. So this is Alpha Centauri, which gets to be about 3 light years from us.
Mhm.
Barnard's star gets to be around just under 4. And right now it's at 4.5.
It's at 6. That was the Alpha Centauri line you just touched. Alpha.
Oh, yes, Barnard's star. Yes, I meant Alpha Centauri. Yeah. Okay. And these are other close stars.
Can I ask this?
Yes.
Alpha is a 3-star system, right?
Triplet,
Proxima is
yeah.
only one of them.
It's a triplet.
Okay, and what
So
are
where one goes, the whole crowd goes.
Yeah.
But are the other two? Proxima is the small one, which is a red dwarf, right?
Yeah.
It's closest to us. And the other two, do they have names separate from Alpha?
Alpha Centauri A and B.
Just A and B, and yet Proxima gets its own little name.
Just because it's the closest right now, it's actually officially Alpha Centauri C.
Okay, the word Proxima means approximate?
Yeah.
Perhaps
Means
close.
means close in Latin.
I see. Interesting stuff I learned today. Fascinating.
Okay. Let's see here.
Did any of you see 2010 the follow-up to Space Odyssey 2 and with Roy Scheider going out and
I didn't see that, Ronnie.
the
Mm.
Oh,
one
yeah, yeah.
where Jupiter actually got enough of those black
Obelisks.
monoliths that it became a
Monoliths.
star, and
Yeah, it added to it enough.
I was told it can't be done. It's just not going to become a star, and yet right above its size is,
If you could add mass to it, it would become a star.
well, that's what was happening in 2010.
And Ronnie, the size is deceptive because you could keep adding mass to Jupiter and it just compresses the core more, so it doesn't get all that bigger. So the brown dwarfs aren't that much bigger than Jupiter, even though they have 17 and 18 times the mass of Jupiter.
And I'm sure we've talked about brown dwarfs, but my basic question is that something between a planet or a gas planet and a star, not quite burning, not fusing, but not.
It fuses deuterium for a while, in a brown dwarf. So it has some fusion that goes on, but then it sputters out.
And it's bright enough to see like a star.
In infrared, especially.
Okay, got it. What are we looking at here, Mr. Prez?
This is a map of our sun in the middle, and the nearest stars out to, what does it have? The 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 light years. And this is Alpha Centauri. I don't know why it has 2 arrows. Maybe there was an argument when they drew this. Barnard's star is over here. It's mostly going laterally from our sun, not heading toward it. There's Lumen 16, Leyland 21,185, and Wolf 359 out here. Wise and Sirius out here at just under 9 light years, and Luton up here. So Sirius is the brightest star in our sky, and it's bright because it's close, not because it's particularly gigando.
It's 9 light years away.
Mhm.
Wow.
Okay. Now we're going to change over to the realm of giant stars.
Ooh.
So
Yeah.
this is Aldebaran, Rigel, Antares, Betelgeuse. This is pretty big. It's going to go supernova sometime after midnight.
Yeah, according to Tom Totten.
Yeah, and then rescaling, repicturing it with Betelgeuse now having this size, you get to VY Canis majoris. I don't know what this is, but Cygnus. And this one we're going to look at UY Scutum, which is 1,700 solar diameters in diameter. So this would reach out to Jupiter. This shows a picture of the sun right there. Earth's orbit, 300 million kilometers. And this shows the UY Scuti, which is fairly large. I don't know where they got this structure for its surface, drew it in there, just brushstroked it in, or maybe it's big enough that they can see it.
I think that's from an image of Betelgeuse, but
yeah, that's what it looks like. Yeah.
Is this the biggest?
One of the biggest.
It's believed to be the biggest. There are 4 or 5 that may be contenders. They're as it explains in the talking points, these stars are frequently associated with a large amount of dust outside of the star, so it makes them hard to measure. And they are really, at that big, they are really very fluffy.
Yeah, and they vary in size too.
Yeah, so they vary in size. So this is the constellation of Scutum with Aquila up here, and Gamma, Alpha, and Beta Scuti in there. And this is where UY is located, down near M16 and M17. And this puffy cloud here is unresolved star clouds in our galaxy. This is a photograph of the star. Not very dramatic.
And you can see a lot of reddening by dust.
Yes, that's what that's due to.
And even in the stars all around it too.
Yeah. Except for a few stars that are closer to us than the dust is.
Yeah.
This is a light curve for UY Scuti. It changes from our point of view from 10.6 magnitude down to 8.4, which is almost 3 orders of magnitude. And it's there is a pattern here, a periodicity, but it's fairly irregular. I didn't read what the interpretation of this was, whether it's an oscillating star this big, or it's got a companion that's doing funny things to it, but it's pretty big to try an eclipse. So.
Wow. So it would never be classified as a variable or a Cepheid or anything like that, I guess.
It is a variable.
Oh,
That's
it's
what
definitely a
UY
variable.
means.
That's right, Chuck.
But it's not regular. It's irregular, as we noticed there.
Yeah.
Hmm.
It may have multiple patterns superimposed. You got to go do a Fourier analysis on it.
Yeah.
How would the Garnet star, Herschel's Garnet star, fit in that? Would it be as big as Scuti, about
No.
the same size?
I don't think so.
It's up there, but it's not as big as these guys.
My cat has decided to help me out here.
He's gonna unplug you.
Well, can I fill this briefly with a quick question?
Please go ahead.
We know in our own solar system, we have all these layers. You got the inner sanctum, which is the planets and moons. Then you got a Kuiper belt. Then you got a Oort cloud.
Yeah.
Out to a year and a half light show or a light. I just wonder if science thinks all stars, including the big ones, have at least that number of shells and outward rings, but we can't see them.
I don't think all have, but quite a few do. It depends how they form, and a big star like that might blow stuff away.
Yeah.
No way we have of ever seeing them or detecting any of those.
Yeah.
Well,
Ron, there was a subcategory of Cepheid variables that I studied with my students at Westmont called delta Scutis. Okay. But these are stars that have cycle times in the many hours. Okay. I think Jerry's thing was way, way longer periods of time for these things to fluctuate.
Mhm.
Okay.
And they actually expand and contract, or do they just
Yeah.
change?
Right. And there was one that I was working on with David, can't remember his last name. Um, and we saw secondary structure. So we saw the pulsation mode easily. So where the star breathes in and out. Okay. But then there were also ripples. There was ripples in the data that showed us that there was a secondary oscillation that the star underwent. Okay. It was kind of a neat discovery.
Have we reached a point where we could determine that such stars couldn't possibly have planets that would hold life, or maybe even have planets, period? Because that would have nothing to do with their expansion, their changing. Imagine the
I don't
sun.
think you can say never.
Those giant stars are what sometimes we project as our star in the future, not going to become nearly that giant, but it's going to grow out to where the outer reaches of our sun reach the Earth's orbit.
Yeah, I was going to say, Jerry, very interesting. Not on your topic, but Isla got another helper at the Palmer, and he showed up yesterday. His name's Connor. He's a grad student over at UCSB, and he studies pulsating brown dwarfs. It's kind of interesting. Pulsating brown dwarfs. And I told him that I had studied, Delta Scutis and SX Phoenicius type stars that have periods, that are hours long. You get like 3 oscillations in one evening of data. That's why I really liked them. And they weren't too dim that you couldn't do this work. The star that you're showing is really bright, right? 8.4
Yeah.
to 10 point something.
Yeah.
Two magnitude changes, factor 6, maybe something like that.
Yeah.
Yeah, you can look at the cycle times. If you go to that one peak near the middle and to the bottom near the middle, that's a year and a half. So you'd have to sit up with your telescope an awfully long time to pick that off.
Measure that. Yeah.
Yeah.
So anyway,
That's not like a Delta Scuti. This thing is enormous. This is
Yes.
enormous.
Well, Scooty
I want to
sounds
add a
good.
couple points, and that is that the star's entire life cycle and eventual internal structure is determined solely by the original mass of the star. Everything else follows from that. And when the compression gets of all the mass that's accumulated, that turns on the fusion. And that's where you start burning things, and then you get the layered structure because you first run out of helium or hydrogen, which our sun's about halfway through its hydrogen burning. And it's about 75% hydrogen right now, if I recall correctly. So once that's done, it will shift over to helium burning, and it will go up, and it will have a sort of a layered structure. The whole star inside, someone doesn't just yell, okay, switch, and everybody goes to the other thing. It gradually takes over. So, and these things are, even though they're big, they're not solids. They are plasma fluids. They are at the outer edge, they're probably close to being a gas, very tenuous. So I believe that there's planets that are believed to go actually moving around inside the star for a while before it's used up. But they're not that solid. And when you have something that big that undergoes some kind of a change, it oscillates around that change. So to find a plasma oscillating is not physically unheard of.
Huh. But the light waves that take hundreds of thousands of years to bounce around inside our sun would take an eternity in these suckers to get out, wouldn't they?
Depends how dense it is and what the mean free path of a photon is.
Wow.
If it's not very
Just
dense,
looking at
it won't take
the
very long.
oscillations here, that seems like it's driven by the star itself, but like you said, maybe there's another structure obscuring it every so often. But I would say this star is so big and so complex, it's undergoing some real shivers.
Yeah.
Yeah.
Plus, you
I
can
had to
have,
mute for a little bit because Wally really likes UPS trucks.
and also, when you have different layers with such different densities, you could have different layers
Yeah, right.
shimmering differently.
Yeah. I mean, that's a fascinating star if you have the time to grab all this data over that, expansive time frame.
Well,
So
where is
Jerry's
it?
showing us about 10 years of evolution of the star envelope, you know?
Are these the good candidates for supernovas, hypernovas, or any kind of novas? Do they just,
Because they're massive, yeah.
Yeah.
do they often collapse into a black hole more so than, say, our sun would?
Our sun will not collapse into a black hole. Yeah.
That's
So
why
the
I'm
answer to your
saying.
question is yes.
Yeah.
Fascinating. And where is that fusion taking place? The helium, the hydrogen into helium, is that in the middle of the
In the
star or on
core.
the edges?
Yeah, at the core, Ron.
In the core.
And God knows what this thing is making right now. Do you think it's making just helium, or do you think it's
Oh,
much more
no, I think it's
advanced?
probably got a lot of layers in it, all sorts of
Yeah.
things. As a matter of fact, I was thinking of it in terms of last week or the week before. We talked about Wolf-Rayet stars where they
Mhm.
simply blow off their hydrogen outer layer. And I think a spectrum of this, which I didn't include, but I
Mhm.
didn't find it, would show that it maybe not has a lot of hydrogen on the surface.
Yeah.
Maybe it's Wolf-Rayet star.
Or getting ready to be a
Yeah,
Wolf-Rayet star.
or getting ready.
Jerry, I know I always ask you for this, but plasma, um, no matter what phase it's going through, the plasma's still plasma, right?
Plasma is a phase. There are four
Yeah.
phases of matter. There's solid, liquid, solid, liquid, gaseous, and plasma.
Mhm.
Plasma is where there are no atoms. There's all the parts of atoms.
Right.
And that introduces an extra equate variable into the equation because of plasma, all the participants in a plasma are charged. And so they follow each other around due to the other's magnetic field and electric fields. So you can do what is it?
Magnetohydrodynamics.
That's it.
Yeah.
Good, thank you. Yeah.
Yeah.
Which is one hairy piece of mathematics.
Mhm.
But if most of the creation of the new elements that are higher is in the middle, what's going on out at the edge? Just atoms going crazy and they're not
They're
becoming
not
anything new?
atoms until you get way, way out.
Yeah.
Oh, they're not even atoms. They're just loose protons and electrons.
Yeah.
Plasma.
I just gonna say one more thing, Ron. If you look at the structure of this oscillation, okay, say between 2003 and 2004, can you see how it kind of hops up around 2003 and then it hops up again around 2004-ish? I bet you that's a secondary lobe. I bet you this star is not just pulsating, breathing mode, but I will bet you there's a ripple structure in this thing. And I think Chuck said that you Fourier analyze this thing.
So it has a higher order Legendre
Yeah,
polynomial.
I think there's some beating going on here.
Yeah.
And
That
Period
I
gives
was
you
going to
some.
say also the magnitudes are, within the range of amateur scopes. I wouldn't be surprised if these data came from AAVSO members, like I used to be, American Association of Variable Star Observers.
Yeah.
well, that's like
That's a really cool looking star, but it takes 10 years to get all these data.
The caption says the data is from ASAS, whatever that is.
Oh, never mind. Okay.
but that just means it got brighter. That spike in 2004, and then it got dim in
Yeah,
2005,
yeah. Bright is up, dim is down.
and it took less than a year or about a year to dim that much.
Yeah, a little over a year, it looks
Yeah.
like.
Yeah. A difference of 2, Ron, is about a factor of 6 in brightness. So
In magnitude.
this thing is obviously getting brighter and dimmer.
Yeah.
Okay.
And if the longer the period of the oscillation, it kind of hints that the bigger the object is.
Yeah. Hmm.
And is this normal for all those supergiants? Or
They're
just this
pretty
No.
one?
busy.
Normal. It's common. I don't know about normal.
Common?
Yeah.
Well, Norman, yeah, okay, they all fluctuate.
Yeah.
Certainly, Betelgeuse is doing globular things, and it's bulging and
Yeah, it turns out Betelgeuse, if I remember right, has a partner. It has
That's right. It's got a companion.
Yeah.
really.
And that gives you some of the periodicity.
Mhm.
Not a little white dwarf, is it? Sucking stuff off of Betelgeuse?
It's a smaller star, but it's not, I don't think it's accreting.
Mhm.
Okay. So if it goes in the middle of the night, it'll take that little one with it, won't it?
Actually, it's the little one that will go.
If it's a white dwarf.
Yeah.
Oh, you're losing me again. My God.
And
Fascinating.
that's not what was causing the dimming of Betelgeuse.
It was barfing off, it looks like clouds of stuff
Yeah.
that
Yeah.
coalesced into
And then we're
into
passing in
dust.
front of the star.
Okay.
So what happens if something that size has a planet and it finally sucks it in? Does this planet's atoms suddenly become not atoms? They just all become part of the plasma?
It depends how much energy it gets.
Right.
Well,
First planet has, I know for the Earth, they claim the events will be first our oceans boil, and then of course then there's no possibility of life, so we just become a lifeless rock. There's no melting or plasma going on when the sun expands to us.
Now, can I ask one kind of question? This may not be related, but in one of your star charts, you had something that I noticed was Hind's variable nebula.
Mhm.
And I remember the one was Hubble's variable nebula. But to see Hind's variable nebula, I was kind of going, what is that about? And
seven
this
varieties, 57.
this may be it.
Heinz 57, Ron.
Yeah, exactly. That's right. You're right.
Well, Heinz was totally a visual observer, so
We made great ketchup, though.
I didn't know it was spelled that way.
No,
it's
It may not be in
HINDS.
this. It
It's
may
got a
not be
Z
in
in it.
this one. It was. I think it was up on the upper left. So there it is.
There it is.
Where?
It's just to the right of Aldebaran over there in
The
the yellow.
Hyades, yeah.
Struve's Lost Nebula, and then
Oh, I
Hind's
see.
variable
Heinz
nebula.
variable nebula.
And at first I was going, wait a minute, but Hubble's is completely in a different area of the sky.
Yeah, it looks like your software found Struve's Lost Nebula.
yeah, we can call Otto up and tell him
Yeah.
we found it.
Yeah,
Yeah.
Otto Struve.
So are these nebulas, are they actually a variable star, or are they
No.
different?
It's got dust
Often-
in front of it.
Often they're where a young star is just forming, and it's it's brighter for a while when it's young, but then it goes through a lot of variation because it's got stuff orbiting around it. Still accreting clouds of stuff.
Oh, okay. And I wonder if they all appear like Hubble's variable nebula, like a comet.
It depends.
Yeah, it depends. Okay.
Yeah.
Yeah. Okay. Okay. Well, thank you. I was curious about that.
There's another one in Orion, up near the.
Up near Mesa? Up there, Chuck?
I don't think it. Yeah, it's above the usual representation of M42. And it was discovered by an amateur. It's another variable nebula, and in that case, it's a disk with varying density orbiting around a young star.
Okay. Huh.
Well, I'd love to look at the albums of stuff you guys keep to save all this stuff you see over and over and again, assuming you document it. Maybe you just look and now look at that, Margaret, and then it's gone forever.
Yeah.
Jerry and Chuck and Tom are there. I think Ronnie, you and I are in another class.
Well, I'm sure Chuck saves his occultation somehow. I'm sure he's even part of the National Registry, aren't you?
It's just video files. Yeah, it's just a dot coming and going, so it's not visually stunning.
Okay, well, I have an appointment to keep.
Yeah, and
Hey,
I'll
Jerry.
I got to cut out
shut
of here.
down. We got two things happening. I think Friday night we'll be at Westmont for their star party, and then Sunday afternoon we have a celebration for the life of one of our own from the screen who passed away in December, Bruce
Yeah.
Murdoch, out in Isla Vista.